And we have money metric utility function. One of the common problem in our utility that we have is utility is not observable. We cannot count that we get 100 utility for drinking water. We can just make preferences or compare. This one is, I prefer this one to that one. By how large, we don't know that one. We cannot observe. So there is one way to observe that, our utility, by using money metric utility function. And we have two types of money metric utility functions, which is direct money metric utility function and indirect money metric utility function. Direct money metric utility function and indirect money metric utility function. So what is this direct money metric utility function? What is this indirect money metric utility function? Let me write down exactly the definition. It explains the minimum expenditure, at prices P, necessary to purchase a bundle at least as good as X. At least as good as X. So it means the minimum expenditure with having prices and some consumption of X, which will equal to the E, P, U, then again as a function of X. So how we can define this relationship? So you know that this EPU is expenditure function. And this MPX is your money metric utility function. What the money metric utility function says, the minimum expenditure at prices P, at this prices P, necessary to purchase a bundle, for example, this X or any bundle, that provide at least as good as X level of utility. If you remember, in our expenditure function, we didn't have any X here. In expenditure function, we already had EPU. But here we have EPUX. We include a bundle that at least as good as this X. So this is our utility in terms of money. In terms of money, we can observe in terms of how much money we pay. So if we write down the definition for indirect money metric utility function, we says that how much money one would need at prices P to be as well off as one would be facing prices Q and having income M. So how we can write down that the indirect money metric utility function as a mu as a function of P and some other prices, which is Q, and our income level, which is equal to E, P, then V, QM. So, what this relationship says, it says how much money one would need at prices P. When the price is P, how much money do we need to be as well off as if we have the prices Q and income M? So what does it mean? For example, we want to buy some goods. Suppose that Q is equal to 2. Q is equal to 2. And income is equal to, for example, 100. Our income is 100. And if the price is equal to 3, if the price is equal to 3, then now how much money do we need to pay these prices, which is 3, to get exactly the same level of utility when the price was only 2 and the income at that time was 100? But now how much do we need? Now how much do we need to buy some goods and services that while the price was 2 and the income, what's happening? And the income was 100. So now, how much money do we need? If the price change, how much the income should change to have exactly the same level of utility? So it's a kind of extension of the utility maximization process. So if you remember, in the utility maximization process here, we had EPU, VPM. But here, instead of VPM, we have QM with some different prices. Here, we had EPU, but we have EPUX. EPUX. So let's write down an example for this one, for the direct manometric utility function. Our EPU in terms of Cobb-Douglas was that one. U multiplied by P1 to the over alpha to the power of alpha multiplied by P2 over 1 minus alpha to the power of 1 minus alpha. So we, from the last slide here, if we change this one to E, P, U as a function of X, here just U is here just then a function of X, then it's equal to our direct manometric utility. Our direct manometric utility. How we can find that? It's easy. So instead of this part, exactly write down its own. Write down P1 divided by alpha to the power of alpha, P2 over 1 minus alpha to the power of 1 minus alpha. Here, instead of U, write down UX. Instead of U, write down UX. And in our Cobb-Douglas loss function, our UX was equal to x1 to the power of alpha, x2 to the power of 1 minus alpha. So then, our direct manometric utility function, MPX, will be equal to P1 divided by alpha to the power of alpha, P2 over 1 minus alpha to the power of 1 minus alpha multiplied by x1 to the power of alpha, x2 to the power of 1 minus alpha. This is our direct money metric utility function. Our direct money metric utility function. Now, it's observable. Why it's observable? Because this direct money metric utility function is a function of price and consumption bundle. P is observable, P1 is observable, P2 is observable, X1 is observable, X2 is observable. All of them is observable. But here, EPU as a function of U, P1, P2. P1 observable, P2 observable, U is not observable. But by using direct money metric utility function, we change it to some function of all observable values, P1, P2, X1, X2. So finally, by having our expenditure function, we can find out our direct money metric utility function, or direct money metric utility function. And also, by having this expenditure function, which is E PU is equal to U multiplied by P1 over alpha to the power of alpha, P2 over 1 minus alpha to the power of 1 minus alpha. Then, here we have mu as a function of P, Q, and M is equal to E as a function of P, V, Q, M. So, now, we have our expenditure function as a function of P and U. We can write down as a P, V, PM. From the important identities, as we already talked about that, U is equal to VPM. U is equal to VPM. But this function can be changed to indirect money metric utility function if we substitute P to some other prices Q. Some other prices Q. Then mu as a function of Q and some other prices Q and M is equal to E as a function of P, V as a function of Q and M. So now, how can we find that one from here? And instead of U, write down VQM and leave the other part itself. So our indirect money metric utility function, which is a function of P, Q, and M, is equal to, instead of U, write down VQM. VQM multiplied by P1 over alpha to the power of alpha, P2 over 1 minus alpha to the power of 1 minus alpha. We know that this indirect utility function for the Cobb-Douglas is equal to P, Q, and M. If you remember, the VPM was equal to M multiplied by alpha over P1 to the power of alpha, then 1 minus alpha over P2 to the power of 1 minus alpha. This was our indirect utility function, but it was a function of P, but now we have indirect utility function as a function of Q. Then what we can write down, we can write P1 over alpha to the power of alpha, P2 over 1 minus alpha to the power of 1 minus alpha. And instead of VQM, write down the value. What value? But substitute Q instead of P1 and P2 here. And instead of P1, write Q1, and instead of P2, write Q2. Then this will be equal to alpha q1 to the power of alpha multiplied by 1 minus alpha q2 to the power of 1 minus alpha. So finally, this is a function of p. Okay, we have one m here, and multiplied by m. You see now, this is which is a function of p, q, and m. It's a function of p1, p2, q1, q2, and m. p1, q2, and m. So this is the indirect manometric utility function. As we see here, again, we can observe the p1, p2, q1, q2, and m. p1, p2, alpha 1, q1, q2 were observable. But here, in this function, u is observable? No, we cannot observe u. But here, we can observe p1, p2, q1, and q2, q2 and m. So this is the indirect manometric utility function. So this is the direct manometric utility function for this Cobb-Douglas utility, or this Cobb-Douglas utility function. And this one is the indirect manometric utility function for that Cobb-Douglas utility function. So it's easy. It's difficult. So when we have our utility function, and if we have expenditure function, then it's easy to find out the direct manometric and indirect manometric utility function. But if we don't have expenditure function, so it will take a long process. It will take a long process because at that time you have to maximize your utility, you have to find your indirect utility, then expenditure function, then direct manometric and indirect manometric. But if you have your utility function, indirect utility function, and expenditure function given, the three is given, just change the value. And instead of U, write down VPM, and instead of P, then write down Q. And here, for the direct one, and instead of U, just write down UX. And instead of UX, then write down this function. But the thing is, if we have our utility function, if we have our indirect utility function, and if we have our expenditure function. If we have these three, then we can find out the direct manometric utility function and also indirect manometric utility function. We can find out that this direct manometric and indirect manometric for all the types of utility function that we have. This was the example for Cobb-Douglas. We can find out for CS, for perfect substitute, for perfect complement, for quasi-linear. But we have to have that three things. If we have this one for any type of utility function, then we can find out the direct manometric and indirect manometric.